What is the buffer solution? Buffer solution is mainly composed of a weak acid and its conjugate weak base. Let me give you some examples of that. Hydrofluoric acid HF is a weak acid. The conjugate base of HF is fluoride. All you have got to do is remove a hydrogen from the acid to know its conjugate base. I will pair up fluoride with sodium to form the salt of hydrofluoric acid. So here we have the weak acid and the conjugate weak base together. These two components form a buffer solution. Another example will be acetic acid, a weak acid, and its conjugate base CH3COO-, and we'll pair it up with sodium ion. So sodium acetate will be the weak base. These two components, when they combine, they create a buffer solution. The purpose of a buffer solution is to maintain a constant pH level throughout the solution. It resists change in its pH, and it has the ability to do that because it contains both a weak acid and a weak base. Let's say if we have a solution of HF and a sodium fluoride, and if we were to add acid or anything that would increase the concentration of proton ions H+ or hydronium ion, then the added H+ is going to react with the weak base component of the buffer solution. So here it's going to react with the fluoride, and we are going to get HF and water. What is happening here is fluoride consumed the incoming hydronium ions in the solution and prevented the dramatic decrease in pH, or we say no significant drop in pH. Let's say if we add a strong base like sodium hydroxide. Hydroxide ion is going to react with the weak acid component of the buffer, so it's going to react with HF. HF is going to consume the hydroxide ions, creating fluoride and water. Consequently, we are not going to see a sharp increase in the pH, but the pH will increase slightly because hydroxide ions are being reacted with HF. This is how a buffer solution can maintain a relatively stable pH level in the solution upon the addition of strong base or strong acid.